in this video, I will explain how the attention mechanism works in the transformer model. The attention mechanism is core to the transformer model that was proposed in 2017 in this paper called Attention is All You Need. This model, which is shown here in this diagram, is the foundation of most modern large language models. The attention mechanism allows the model to decide which words are important when interpreting each word. I'm not going to be able to cover everything. I'm going to focus on the attention mechanism, and I'm going to assume that you know how words are turned into vectors as embeddings, the dot product, and the softmax function. I will briefly explain them before I use them. But if you want a deeper dive into these concepts, I would recommend that you watch other videos first. The attention mechanism first computes an attention score between a focal word, which we call the query, and each word in a sentence. The attention scores are then blended together to produce a context vector, a context-aware representation of the focal word, which is the query. The idea is that a sentence or a document can be very long, and the model really needs an efficient way to figure out which words are more relevant to the focal word that we're analyzing right now. And some of the words are more relevant than others, and so we need to know what to pay attention to and what to ignore. Here's a sentence. Julie asked Beth to see her. And if we focus on the word her as the query, then what we can do is to compute an attention score between the query, her, and all the other words in this sentence, actually including her, herself. And that attention score is going to be used to compute a more context-sensitive representation of the query. And all that computation is done using this equation over here, this attention equation. And this video is going to show you step by step how that equation works. The attention mechanism uses the dot product. And here, let me briefly explain what the dot product is. You may think your language models are very smart, but in fact, your computer doesn't understand any word. Every word has to be turned into numbers because your computer can only compute. And so here, let's look at an example. We can represent Julie as a set of two numbers. So this is called a vector of two numbers, 1, 1. And then Beth, as the second vector, is represented as 4, 5 here. So these two numbers. And the dot product really is a calculation of how these two vectors relate to each other. So let's just illustrate these two vectors on an XY plane. So 1, 1 would be like over here, and 4, 5 would be 1, 2, 3, 4. 1, 2, 3, 4, 5 would be around here. So this would be our vector A, Julie. And this would be our vector B, Beth. The dot product is really a sum of product. We can implement it in Excel using sum of product. You can look at this formula over here, and you will see that I actually just use sum of product to compute the dot product. So the dot product is 1 times 4. So the first two numbers multiplied together plus the second set of numbers multiplied by together, and this gives us 9. And this dot product is a measure of how similar or how close these two vectors are to each other. If this is Beth and this is Julie, even though the lengths are the same, but if they are further apart away from each other, they will get a smaller dot product. And this will be a larger dot product. So dot product, the size of the dot product tells us how similar these vectors are. Softmax is a math equation. So here's the math equation that looks quite intimidating, but it's actually pretty easy to understand. And the purpose of the softmax function is to take any set of values as input and convert them into a set of probabilities or percentage values that add up to 1. So let's say that we have these three values, 2, 3, and 5. They add up to 10. And what we will do is take the natural exponential. So this is the natural exponential. So this will be e raised to the second power, e raised to the third power, e raised to the fifth power. These three numbers now add up to this total. And then we will take each number, divide by the total, and that will give us 4%. This number divided by the total gives us 11%. This number divided by the total gives us 84%. And then these are numbers that look like probabilities. We can treat them as probabilities, and they do add up to 100%. So again, the softmax function is used to take a set of numbers and turn them into a set of probabilities that add up to 100%. And now we are ready for the attention mechanism. So I have created this Excel template to help us walk through the attention mechanism step by step, starting with the raw tokens at the bottom. So the tokens are the words over here. So Julie asked Beth to see her. These are the original words, and each word is treated as a feature, X1, X2, X3, and so on. But because our models don't understand any word, we have to represent them as a set of numbers. So here we're going to use a two-dimensional, use a vector of two numbers to represent each word. Okay, so these will be their embeddings. But in addition to embedding the words, we also embed their positions. So the fact that Julie is the first word, as is the second word, those positions are very important. And we can also represent the positions using these embeddings. So with these numbers, we can now add them up to create our input vector. So the input vector is a combination of the token embeddings, which embeds the words, and also the positional embeddings. And we simply add them up to create the final input vector. These are then used as keys. And then we are focusing on the last word as the query. And so what we're going to do is we're going to create these attention scores by calculating the dot product between the focal query word and all other keywords. So let's look at this query word, and that input vector is 4, -1. And now I'm going to do a dot product between the query and the key. So that would be -12 plus -2 multiplied together, and that gives me -14. 3 multiplied by 4 is 12. 2 multiplied by -1 is -2. So together they give me 10. 4 multiplied by 4 is 16. 0 times -1 is 0. So this is 16. -4 times 4 is -16. 0 times -1 is 0. So -16. 3 multiplied by 4 is 12, plus this -1 gives us a +1, so this is 13. And then we actually use her as a key as well. So we'll multiply itself with itself. So 4 times 4 is 14. -1 squared is 1. So this one is 17. And now the next step is to scale it by this number dk. So dk is D stands for the dimension and k is key. So we're looking at the dimension of the key vectors. And the dimension is 2 because we have two numbers. So basically this is saying we'll take this number and divide it by square root of 2. So this will be negative 14 divided by square root of 2. 10 divided by square root of 2, 16 divided by square root of 2, negative 16 divided by square root of 2, 13 divided by square root of 2, 17 divided by square root of 2. And then once we run these numbers using our calculators or using Excel, then we can feed them through the softmax function, which will turn all these numbers into percentages that will add up to, so these numbers will add up to 100%. So they will, basically, we can use the softmax output values as percentages and multiply this percentage with this input factor plus this percentage multiplied by this input factor and add all of them up as a blend to create the final context factor to represent this query word. So the idea is really to figure out what percentage of this word, 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 and what percentage of this word should be blended together as a way to represent the query word. So the final query is context aware because all the other words are the query words context. We can navigate to the Simple Attention Solution tab and see how I have built the formulas to automate all these calculations. So you can see that the attention score here, these are just sum of products because they are dot products. And the scaling is taking this number and divided by square root of 2. And I do that with every number. And here, the softmax, I have all the exponents here, and I have just built these equations in Excel. And then these are turned into percentages. And finally, this vector is the first percentage multiplied with the first input vector, the second percentage multiplied by the second input vector, and so on and so forth. And this is how we blend all the keywords together to form the context vector for the query. Now, this is a very simplified version without any weights for training. In actual implementation, the attention mechanism is always implemented with weights. So this is a more complex version with weights included. As you can see, we follow the same steps. It's just that during the training process, we would add some weight matrices. So this step, we add some trainable weights that can be tuned during training. And here's another step where we add some weights. I have solution file here for the version with the weights. And in reality, we never really represent embeddings using integers. I really pick these whole numbers just to simplify the math. However, in reality, embeddings are always decimal value numbers. So here is a version with more realistic embeddings. And you will see that the numbers look a little bit more complex. And you see that lots of decimal values. But the equations, the calculation steps are exactly the same. And that's it. I will include some resources, some references in the notes underneath the video. And I will also include a link to this Excel spreadsheet.